Mercury, the smallest planet in the solar system, is often overlooked by astronomers, but the closest planet to the Sun is truly an incredibly interesting place. Welcome to the Daily Galactic. Today we're talking about the beautifully unique planet of Mercury. Named after the Greek god Hermes, which is translated into Latin as Mercurius, it takes only 88 days for Mercury to complete one trip around the Sun. This is the shortest year of all the planets. As an inferior planet, meaning it orbits the Sun within the Earth's orbit, it can only be seen on the western horizon after sunset or on the eastern horizon just before sunrise. This can make it difficult to study on Earth, but orbiters sent there have had no such problems. The orbit of Mercury is unique in the solar system. It's tidally locked to the Sun in a 3-to-2 spin-orbit resonance. This means for every 2 trips around the Sun, it rotates only 3 times. So remarkably, as seen from the Sun, the planet only rotates once every 2 years. On Mercury, one day would occur every 2 Mercurian years. It also has the most eccentric orbit of all the planets and the smallest axial tilt. At perihelion, its closest point to the Sun, it's only about 2/3 of its distance at aphelion, the furthest point of its orbit. This varying distance to the Sun has an effect on Mercury called tidal bulging, which is 17 times stronger than the tidal bulging of the Moon and the Earth. Combined with the 3-to-2 orbital resonance, the result is complex variations of the temperature across the surface of Mercury. On the topic of Mercury's surface, it's very similar in appearance to the Moon. Heavy cratering and desolate plains indicate that the planet has been geologically inactive for billions of years. During its formation almost 4.6 billion years ago, Mercury was bombarded by many comets and asteroids. Throughout this intense period of crater formation, Mercury received impacts over its entire surface. It didn't help that Mercury also has no atmosphere to burn up meteors like the Earth does. Around this time, Mercury was extremely volcanically active, where basins such as the Caloris Basin, which is still there today, were filled to the brim with magma. These molten lakes eventually solidified over and created vast smooth plains that are very similar to the ones found on the Moon. The craters found across the surface vary dramatically in size, with some being huge multi-ringed impact basins hundreds of kilometers wide, to small dents just dotted around. They also appear in all states, from fresh craters to highly degraded craters, and the largest of them all is the dramatic Caloris Basin, with a huge diameter of 1,500 kilometers. The powerful impact that created this crater caused massive lava explosions and left a concentric ring over 2 kilometers tall around the crater, a quarter the size of Mount Everest. Another notable basin is the Tolstoy Basin, that features a 500-kilometer ejecta blanket that has slowly been filled by smooth plains material. The Beethoven Basin also features a large ejecta blanket of similar proportions. Smooth, gently rolling plains can also be seen in between the damaged terrain. These regions are the oldest surfaces of Mercury. Most notably, a smooth plains area fills in a wide ring around the Caloris Basin. The plains on Mercury, unlike the plains on the Moon, have an incredibly similar albedo to the older intercrater plains elsewhere on the planet, meaning that they reflect the same amount of light as each other. One strange feature that can be found across Mercury are unique compression folds. These are believed to have originated as Mercury's interior cooled, contracted, and deformed, creating wrinkled edges all around. After Mercury was mapped, it was suggested that the planet has had a total shrinkage of its diameter somewhere between 1 to 7 kilometers. These folds can be anywhere from 1,000 kilometers in length to 3 kilometers high. There have also been smaller ones found that are only tens of meters high, and they're believed to be less than 50 million years old, signifying that this compression process is still occurring to this day. The Messenger spacecraft that orbited Mercury was able to find evidence of lava flows from ancient shield volcanoes. 51 lava deposits were found along the surface, with 90% of them being found within impact craters. Volcanic vents were also discovered around the well-studied Caloris Basin. At least 9 were found, each being up to 8 kilometers in diameter. The surface of Mercury appears to be a solid silicate crust and mantle, with a solid iron sulfide outer core and deeper again a liquid layer and then a solid inner core. Geologists think that Mercury's core takes up a massive 55% of its volume. In comparison, Earth's takes up only 17%. Its core has a far higher iron content than any other major planet in the solar system. Because of this, it has the second highest density in the solar system as well, just slightly less than the Earth's. As Mercury is much smaller than Earth, and its inner regions are less compressed, its core must be very large, dense, and mostly made of iron. The final feature of Mercury that we'll talk about is its unique surface temperatures. It can range from -173 to 427 degrees Celsius, or -280 to 800 degrees Fahrenheit. And because of its closeness to the Sun, the side facing it can reach extremely hot temperatures, whereas the shadowed regions and the dark side of the planet can reach incredibly cold temperatures. In fact, craters on the North Pole that are permanently surrounded in shadow were found to contain frozen water ice. It was discovered through radar, as water ice strongly reflects radar, and in the early 1990s high radar reflection was detected at the North Pole. Although water ice isn't the only possible cause for that, astronomers all agree that this is the most likely option. Where this ice comes from, however, is still a mystery, with one of the most likely theories being that it is leftover deposits from water ice comets that impacted onto the surface. So there you have it, everything you need to know about the wonderfully unique planet Mercury. Let me know what your favourite planet is in the comments below, and if you have any questions, feel free to ask them. Thanks for watching all the way to the end, and be sure to leave a like if you enjoyed and subscribe for more videos every week. See you soon.